All right, here we go. Let's start with section 2.4, which is proving statements about segments and angles. We are finally at the part where we're going to be able to prove something is true or false. What exactly is a proof? Well, let's take a look at our first vocabulary term, a logical argument that uses deductive reasoning to show a statement is true. Remember, we talked about two different types of reasoning. We had inductive reasoning and deductive reasoning. Deductive reasoning is the one that uses facts, definitions, accepted properties, laws of logic. That's why I kept making that. I stressed it so much and was saying, you guys have to remember all these different things that we've learned in chapters 1 and even up to chapter 2, because we have to use those properties, facts, theorems to help us prove whether two angles are congruent or two segments are congruent. And those are things that you're going to be doing coming up. So how we work out a proof is by doing what we're by writing them out in a fashion called a two-column proof. You have obviously two columns, and then what happens is that we have a numbered statement and corresponding reasons that show an argument in a logical order. So we'll say like 1. You might have a diagram and it shows you that angle 1 is congruent to angle 2. And so we'll write that down. Angle 1 is congruent to angle 2. What is our reason? For that, it simply would be given. Okay. And then we've looked at theorems, a statement that can be proven. Different from that of an axiom or postulate, because those are statements that we just accept without proof. So let's take a look at theorem 2.1, and we have properties of segment congruence. Remember in the last section we looked at these three properties: the reflexive property, symmetric property, transitive property. And we said that they could be used with real numbers. We could use them with segments and also in angles. So when you look at theorem 2.1 and 2.2, we have all those three theorems or the properties used for either segments and angles. Remember, with the reflexive property, think of reflection as the same exact thing on the other side of the equal sign. So you see right there, segment AB is congruent to segment AB. The same thing we could say for angles. Angle A is equal to angle A, or congruent. Since we're specifically talking about congruence, we need to make sure we do use the congruent symbol. There are times where we'll go from congruence to equality, and then I'll show you what reasons we'll use for that. Symmetric property, remember, it's not exactly the same statement. We actually flip the statements. So right there in the example, you see that AB is congruent to CD. Using the symmetric property, we can see that CD is congruent to AB. It means the same exact thing, we just switch the order. And then with the transitive property, we have three different segments or three different angles, and we make connections between all three of them together. If AB is congruent to CD, CD is congruent to EF, then AB has to be congruent to EF. So what you see right here is an example of a two-column proof. Let's go ahead, I'll read this for you. It says, in a proof, you make one statement at a time until you reach a conclusion. Because you make statements based on facts, you are using deductive reasoning. Usually the first statement and reason pair you write is given information. Okay? Usually, not all the time, but let's just say probably like 99% of the time that's going to be the case. The reason why sometimes it may not is because you got to think about this. When you're proving something, you're trying to like write a story. There's a beginning, middle, and end. The beginning is usually, you put the information that you know. So that's why we have the given. So right here in this in this diagram, or in the first problem right here, it says, it says copy. In the diagram, it says we have angles 1 and angle 2. And then it says copy or draw the diagrams and label given information to help develop proofs. Okay. Do not mark or label information in the proof statement on the diagram. So you can see right here, statement 1, and we'll always write it like this. Okay. 2-column proof. We have 1 column is the statement, the second column is reason. Number 1, angle 1 is congruent to angle 2. That is given. Okay. Now, how am I? They also in the problem they show you, all right, what's given. And they're going to tell us what is it that we're proving, that angle 2 is congruent to angle 1. So how do we do that? Well, it says in statement 2, I can go from equality or congruence to equality. So that's why in statement 2 it said measure of angle 1 is equal to measure of angle 2. And we will just go ahead and say the definition of congruent angles. Because remember, if I know that angles are congruent, they are also equal. That's why you see next up, they went from angle 1 to the measure of angle 1. Because when I know how big the angle is, then I can go ahead and use equality. Since we're talking about the measure of angle 1, therefore they changed this to equal. Next, statement 3 was measure of angle 2 is equal to measure of angle 1. Well, what did we learn today, or what were some of the different, some of the different properties that we just we covered again, where we took the statement from before, and the next thing you know, the order has switched. Well, that right there is our reason for number 3, the symmetric property of equality. And then finally, remember, what we're trying to prove right here is that angle 2 is congruent to angle 1. Well, that's for our last statement. We will pretty much always put the proof down, what exactly we're proving. I can go ahead and say that angle 2 is congruent to angle 1 because of the definition of congruent angles. All right, and so we went from equality to congruence, and then we went ahead and used the definition of congruent angles once again. So in order to prove this, we have 4 statements, 4 reasons, and you have to try to come up with those based on everything that we've learned in the first 2 chapters thus far. So let's take a look at number 1. They've got some of this filled out already. That's to kind of help you and get used to writing proofs. And so let's do this one together. Now, so remember, the very first thing that we should always do is write down the given. Sometimes given statements can be seen from the diagram, or given statements can be straight written out for you, as you can see right there. You could a lot of times just put all of the statement 1 and put every given statement down under statement 1. Sometimes they split it apart. I think because this is the first section, the book happens to split everything apart. So the first thing we have here, as you can see, we want to always write down things that we know that are given. So I see up here, it says that segment BM is congruent to CM. All right, so we have that written down. That's given. And then next up, well, what else can we say right here? And then we also might want to look at the diagram. I have BM. I'll go ahead and put a tick mark there and a tick mark for C to M because they are congruent. Okay. It also says that AB and CD, remember, in the beginning it says AB and CD bisect each other. So if segment AB and segment CD bisect each other at point M, we could also say that there are other segments that are congruent. Those other segments can be CM and DM. Those two are congruent as well. Okay. What could also be congruent is BM and AM. All those parts are congruent to each other. So let's see why they may have put these statements down instead of the last part that I just put down, I just mentioned. So segment CM right here is congruent to DM. We can go ahead and say that that right there is given. Okay. Or actually, we have a better, actually one better than that would be that CM is congruent to DM because right here we have a definition of a segment bisector. Using what's given, I'm able to come up with this statement because they didn't specifically say that CM is congruent to DM. They also didn't say that they also didn't say that BM is congruent to DM either. So now we have these two statements, 1 and 2. One of the things that you're going to learn is there's a specific reason why we try to put statements in a particular order. Remember, it's like telling a story. If I take a look at statements 1 and 2 together, that may help me come up with my next statement. I look right here. BM is congruent to CM. CM is congruent to DM. It's like A is congruent to B. B is congruent to C. All right, if I write this down, I'll put A is congruent to B. B is congruent to C. If you look right here, next thing you know, we have BM is congruent to DM. That would be A is congruent to C. If we connect all the statements together, that helps us lead to statement 3 right here, which is one of the properties that we had recovered again today, and that is the transitive property of equality. So you'll see that a lot of times when you solve these proofs, you have to make a connection between two different statements, two of your previous statements. And so it made most sense right here to say, okay, CM is congruent to DM. On number 4 right here, we go ahead and say that BM is congruent or equal to DM. So if the segments are congruent, we can go ahead and use the simple statement right here, definition of congruent, and we'll go ahead and put segments. Definition of congruent segments would be number 4. We went from equality or congruence to equality. In number 5, they say, all right, we have segment addition postulate. Well, let's see what we're exactly trying to prove. We're trying to prove here that AM or AB is congruent to AM plus DM. All right, cool. Is there anything else that we could go ahead and say about AB? Right, if I use segment addition postulate, remember AB is this whole entire thing. I'll go ahead and mark that in red right here, A to B. So what I could say right here is that AB is equal to the two segments that make up AB, which would be AM plus BM. That right there is segment addition postulate, right? You take two small segments, you combine it together to come up with the whole thing. There you have number 5. Now we take a look at number 6, and I look right here. That's my last statement of what I'm trying to prove. Well, how do I prove that? If I take a look and I see the differences between statement 5 and 6, this BM and DM have changed. I see right here on statement 4, BM is equal to DM. And they should be, because remember, think about it, all these segments right here in our diagram are congruent to one another. So finally, what I can go ahead and say is, If I substitute BM with DM, our statement now becomes AB is equal to AM plus DM. And that we will put as our substitution property of equality. And there you have it, your first proof. A lot of the proofs that you will do are very similar to what you see here. You'll see kind of develop the pattern. Maybe use segment addition. Use angle addition if we're dealing with angles. Substitution property is quite frequent. So is that transitive property then. Remember, whenever you go from something being equal to congruent or even congruent to equality, you're going to use definition of congruent segments as a reason. Let's try another one right here. We'll take a look at number 2. All right, we have angle AEB is a complement of angle BEC. All right, so remember, if two angles are complementary, then they are going to be equal to 90 degrees. So we always want to start off with what's given. And so that's why statement 1, angle AEB is complement of angle BEC. Now my goal is to try to prove that angle AED, this angle right here to the left, is equal to 90 degrees. Okay, so let's try to think. Maybe throughout, like, what do we know about something that's 90 degrees? Or you can see right here, we have ourselves a straight angle. We've got, so maybe there's something that we could use as far as knowing about a straight angle. Okay, maybe there's something that we could talk about using, as you can see, maybe angle addition. However, if the reason for number 2, they put right here definition of complementary angles. Well, what do I know about complementary angles? We said it was 2 angles that add up to 90 degrees. So then how about this? Let's go ahead and make that statement right here and put the measure of angle A, EB, if I add the measure of angle B, EC, those 2 angles are equal to 90 degrees. We said they're complementary angles add up to 90. All right, so next up, let's take a look at number 3. We went from angle AEC is equal to angle AEB plus BEC. We took these 2 small angles right here, we added them up, and that equaled the whole thing of AE to C. So that would be your angle addition postulate. All right, so there you have number 3. Well, we went ahead right there and we show that measure of angle AEC is equal to 90 degrees. Maybe there's a connection that can be made. Okay, take a look at statements 2 and 3. If I look at that right there, I can go ahead and say that the measure of angle AEB is equal to 90. I see right here, or AEB plus BEC is equal to 90. I see right here AEB and BEC shown once again. And then I have right here the measure of AEC. There's 2 different ways I can go about giving a reason for this. I would prefer right now, because we've been to try to help you get used to it or familiar with it, think about this. A equals B. Or how about, it will work out this way. If 90 degrees was A, I'll put A above it. This statement right here is B. It repeats itself right here. and AEC is C, look what happens. A is equal to C, or AEC is equal to 90 degrees. So one of the things that we could actually put as a reason here is the, hopefully you know it now, the transitive property. That would be transitive property of, angle congruence. What you could also possibly do is, if you take a look right here, since these two statements do happen to be the same, you could actually say maybe we could substitute AEB plus BEC, those two angles, and equal to 90 right there. And we could technically even say it's substitution property. You may not see it as much in when you do your homework, or maybe when you try to do your answers and big ideas. If I give you like a multiple choice test and you don't have that option of maybe substitution, then you better hopefully find and choose the transitive property. So both could work. Just make sure you are able to justify it. So next up, we have angle AED plus angle AEC is equal to 180. Okay, definition of supplementary angles. Because remember, two angles, we have ourselves, remember we have a straight angle right here. We've got ourselves this line. So if we have a straight line, then that should give us the fact that all the angles combined together, or AED, and angle AEC is equal to 180. Next up, they decide to use the substitution property. Well, what could I substitute in here to try to find that measure of angle AED is equal to 90? Well, let's make a connection right here between 4 and 5. So guess what? If I go ahead right here and I put measure of angle AED plus, and I'll substitute that with 90 degrees, that's equal to 180. In this statement right here, there is no other options but to use the substitution property. So therefore, I think the way Big Ideas has it set up is that if you have no choice other than to use substitution, then you should. If you have the option of using one or the other, then try not to use substitution. All right, and then so finally, we have the measure of angle AED is equal to 90. Hey, what happened to this 90 right here? Maybe mathematically you remember, you do something to one side of the equation, you got to do it to the other. So finally right here, we can go ahead and say that this is our subtraction property of equality for reason number 7. Right, and there you have number 2. Got one last one right here, another fun one. Actually, let's take a look at 3 and 4. Let's see if you can figure out the properties in these statements. I'll look at number 3. I look and I see 3 different little pieces right here. Right, 1, 2, 3. There's a good chance that I would believe that there's a transitive property. Let's see if that holds true. If I go ahead and put that as A, TSU as B, I see TSU again, B, VWX, statement 3, or C. And then finally at the end, right here, A is equal to C. Guess what? We have ourselves a transitive property. So that's the transitive property. And remember, because we're dealing with angles, we can go ahead and say angle congruence. Looking at number 4, if GH is congruent to JK, then JK is congruent to GH. That right there, order's changed, so that should be your symmetric property. Okay, so symmetric property right there of segment congruence. All right, let's finally take a look at the last one and write a two-column proof. Right here, the training wheels are off. They expect you to be able to just look at this diagram and somehow come up with the correct proof. Let's see what we could do. Remember, statement one, we should always put what's given. So let's go ahead and say that M is the midpoint of RT. So if M is the midpoint of RT, there are definitely some things that I should know about this segment. Remember, the segment is going to be split up into, hopefully you realize, two congruent parts. So what I'm going to go ahead and say next is that since M is the midpoint of RT, I'll go ahead and say RM is congruent to MT. Reason, definition of midpoint. Right. Well, if you think about a midpoint, it's going to split a segment in half and create two congruent parts. And so that's what we can go ahead and say that RM is congruent to MT. Let's see what else we can come up with. Maybe I'll look at the diagram. I look at that left-hand side where we have points R, S, and M. Something can be said about that. And think about what we're trying to prove. We're trying to prove that if I add some segments together, it's supposed to equal M to T. So how about this? With these three, I can somehow come up with a statement. The statement is going to be RM is equal to RS plus SM. Right? Why? Segment addition postulate. Right? If I take RS plus SM, that's going to equal the whole thing of RM. So therefore, we can go ahead and say segment addition postulate. It's not easy right now in the beginning, right? You got all these little facts and tidbits that we've learned so far in chapters 1 and chapter 2, and we're learning how we can put all of this stuff together. So now, what else can I say? Maybe what else could I add or change? I do know that RM is congruent to MT. Maybe there's something I could do right here. Maybe there's something I could switch around. I'd say that there's possibly two different ways we can go about this problem. First off, how about let's go ahead and say that MT is congruent to RM. All right, I'm just going to show you this one for the symmetric property, or for the sake of, because I think Big Ideas has the answer where they do this, where they switch the order. And so we'll throw in the symmetric property of segment congruence. You probably don't have to do this, because what I find that what we could get to our proven statement right here is this. So this statement 4, I think you probably don't have to do. If I were to grade this, if you added it, super. If you understand the symmetric property of segment congruence, super. If not, I say that if we take a look at right here, 2 and 3, these two statements, I can make it look like our final statement, which is to prove that MT is equal to RS plus SM. And check this out. What if I went ahead and took this right here, this MT, and I moved that in to RM? Right, so I could have automatically made this MT is equal to RS plus SM. And that would be substitution. And we could have already automatically solved this or have proven this problem. So number 4, for some reason, Big Ideas decide they want to add it. But I'd say that if you do, make sure you use the correct reason. But I think it could have been done without that statement, added statement there. There you go. You now know how to do some proofs, and you're going to be doing it a lot the next few chapters.